In this clip, we are going to see a few more examples of red-black tree deletion. So firstly, if you have not done that already, please go ahead and recall and refresh your memory on the properties of red-black trees. Um, so let's continue to look at some more examples. So let's look at this example 6, where there's a tree that's given here. It's a red-black tree. As you can see that all the nodes here, all the paths here, I should say, has an equal number of black nodes, right, to start with. And we are trying to delete 2, which is this node right here. So first step is we color that as a double black and call that as a DB node. And then, as you might remember from the previous lesson, or the previous session, I should say, from the red-black tree deletion process, right? So we often color the node as a double black node if it's a black node that we are trying to delete. And then we fix that double black node to a single black node by applying a series of cases, right? So first thing first is we look at the sibling. It may be worth recalling that in deletion, we always look at the sibling, right? And then in insertion, if you recall, we always look at the uncle, right? So here we look at the sibling, it's a black sibling. So thereby the parent got to be taking care of this balance here. So we would make that as a double black, right? So this guy becomes a double black. And then the sibling becomes red, right? So that's the kind of starting point, which we call as case 3, is that you could see that we colored that as a double black and then red color, right? And all the cases are outlined in our earlier lesson, so please go ahead and look at that, right? And then we need to fix this 4 here, right? So 4 now has a unique issue, right, that we need to solve it here. So how do we solve it for 4? We look at the sibling, which is black, but then the child, the closest child is red, right? So this is the closest child, which happens to be red. So we apply case 4, and we apply case 4, and we are hoping that we would be able to move this closest child to be on the right side, and thereby it can become the farthest child, right? So we would want to somehow relocate that to be the farthest child, and thereby we turn the problem into case 5, right? All right, so you see that here, then you first step here is to change these colors, right? So we swap the color of 10 and 12, and then we rotate it in the opposite direction from the double black node, right? So in this case, we need to right rotate it. So 10 should go up, 12 would come down. You can see 10 came up, 12 came down. And then somehow we had made sure that now the right child is red, and thereby the farthest child, the child that's located the distance away from 4, or far away from 4, is going to be the red color, right? So thereby we turn the problem from case 4 to case 5. And now in case 5, we would need to swap the colors of the parent and sibling. In this case, we don't need to do that, simply because both are black, right? And then we are going to rotate it towards the direction of the double black node. So thereby we rotate it in the left side, right? So which means 10 would go up, 8 would come down, right? So you could see 8 came down, 10 went up, right? And 4 was the double black node, 9, 2 is the node to be deleted, right? So in case 5, please go ahead and look at case 5 again. that you would find that we would need to change this color of the double black to single black, change the color of that fourth child to black, right? So which we do here, which we did here, and then get rid of that 2. So then you could clearly see at this point all the paths have 3 child, and I'm talking about black child right here. So thereby it's going to be a red black tree, right? So again, please look at this example one more time, and make sure you fully understand this example. It's important that we understand both case 4 and 5 from this particular example, right? All right, so we will take up a tryout 1 problem here where we are given with the tree and we want to delete 2, right? So we want to delete 2, and 2 happens to be a red child, but then keep in mind we may want to do an in order successor, right? And we need to delete 2, and after we delete 2 we will end up with a tree, right? And take the tree and delete 3, okay? So when you delete 3, keep in mind there will be multiple cases, right? So we would need to solve multiple cases to produce our final tree. So please make sure you submit that by our using our general channel by 5 p.m. EST today. And if anyone needs additional time, please work with me here. Let me know, and I will make sure to accept your submission and make arrangement with you. Okay. There's also an optional tryout today. If you would like to try more and practice more, so try to delete 14 from this particular tree, and again you would end up having some fun in this process, because you may want to apply multiple cases, all right, and post your solution as well in the general channel to get the participation credits. So what's the next step for us? So on Friday we will look at some more examples on trees delete. And then next week, we will start working on graph-based algorithms, right? So we will start talking about graph data structure and some algorithms that's related to a graph data structure. Okay, so there's also a reading assignment for today, the Sedgwick trees. If you have not done so already, please take a minute to do the reading assignment, and if you have any questions, feel free to ask. Okay. Finally, I want to make one quick note about our lab this upcoming week. We would not have any new lab session this week. Instead, we are going to take up the lab time to work on the project proposal. As you would have seen from my message early this week, we have a submission for the project proposal this Friday at 5 p.m. So I like to make sure everyone has the time during the lab session to finish up your proposal document and make the submission by 5 p.m. Eastern time, right? And if you have any questions related to your project, feel free to ask me through direct messaging in Slack, and we can talk about your individual questions that way. Okay. I'm also going to talk about the project proposal and our lab session more on Friday class session. Okay. All right. Thank you.